Hi, my name is John, and I'm a tutor for calculus students. One of my students came up with this question, the 2006 Calculus BC Form B, and it was question number 2, and I didn't have enough time to actually go over this question with her, so I decided to just YouTube this video, just in case some students might need to know how to do this question. So the question looks something like this. Let me get this out right here. It says an object moving along a curve in the xy plane is parametrically stated x as a function of time and y as a function of time at time t, where dx dt, that's x prime, with tangent of the x e to the negative t power and dy dt. The instantaneous change of y with respect to time is the secant of e to the negative t. And it tells you that for time t greater than or equal to 0, at time equals 1, the position is going to be 2, negative 3. So you're probably going to need all of this information sometime during the for process. So let's actually, so I wrote the problem out for you really nice, neatly. X is a function of time and y is a function of time. So the independent variables are time here, and the dependent variables are the x and the y. And they give you the parametric equations already. And for time t greater than 0, t equals 1. And the position is at 2, negative 3. So let's start with the process for part A. It says write the equation for the equation of the tangent line to the curve at 2, negative 3. So you want the equation of tangent line. So how do you find the equation of the tangent line? You have to first find the slope. Slope, if it's given in parametric equation, is dy over dx, which is the same thing as we put dt in the denominator here, so it becomes dy dt divided by dx dt, and these are your two variables right there, so we just put it on top of each other, dy dt, secant of the e to the minus t power over the tangent of e to the minus t power. Since the inside is the same here, we can simplify this. That becomes 1 over cosine divided by sine over cosine, multiplied by the reciprocal, cosine over sine. Cancel that out. The cosines cancel, and it becomes 1 over sine of e to the negative t dt. So that's your slope at time t equals 1. Is it t equals 1? Yes. Yes, you want at time t equals 1. So given that portion right there, you can use y equals mx plus b, which is a slope-intercept form, or you can use y minus y1 is equal to m times x minus x1. You can use a point slope form. This is the preferred usage because it's a lot easier to use on the AP exams. So the equation is at the point 2, negative 3, right there. So you plug this in. Y minus negative 3 is y plus 3 is equal to 1 over m. 1 over the sine of e to the minus 1, because you're going to plug in t equals negative 1, t equals 1 in here. So you get sine of e to the minus 1 times x minus x naught, which is 2. And that's it. And that's part A. Let me see. You can either put it like this, or you can actually evaluate this out on your calculator if you want to. Just make sure when you do this, where sine of e to the minus 1, you have to make sure that you're on radians mode here. So I don't know if you can see this or not, but there we go. So the reflection's a little bit better. Let me open this up. So you have to go make sure you're in the radians mode right here. So check the mode, make sure you're in radians, and take the sine of e to the minus 1. And then that should be approximately 3.3596. It's approximately 0.3596. And let me just check on that. If you take the, 1 over that to the minus 1 power, 2.78. So 1 over sine of e to the minus 1 is approximately 2.7806. 2.7806 approximately. Okay? And so there it is right there. That's part A. Let's do part B. I'm going to just use the back. Okay? Find the acceleration. That's what you're looking for. Acceleration vector. So it's going to be in vector notation like this, and you want the speed. According to the acceleration vector, you have to take the derivative of that. That becomes d squared x over dt squared. That's the acceleration. The second derivative is the acceleration. And so given dx dt is equal to tangent of the e to the minus t, the derivative of the tangent is secant squared. You should know that from your at the very beginning of the course. So the derivative of tangent secant squared, and the inside stays the same, times the chain portion, e to the minus t, is itself times the derivative of the inside of negative t, which is negative 1. So the derivative of that becomes negative e to the minus t secant squared of e to the minus t. And that's what do you call it? Evaluated at t equals 1, right? And that's going to be your x coordinate. And how about your y coordinate? So let's actually do this. Negative e, let me see if you can see this or not. I think you're able to see it a little bit. Negative e to the negative 1 times secant squared is, I'm going to put parentheses. I have to get out first, so delete that. So it's negative e to the minus 1 divided by parentheses cosine of e to the negative 1. Get out of there, get out there. And parentheses, and then I have to square that. That becomes negative 0.4225 approximately. And that's your x coordinate, and your y coordinate is take the derivative of the y function. Where's your y function? The y function was dy dt is equal to secant of e to the minus t. So take the derivative with respect to time of that. You get the second derivative. The derivative of secant is secant of e to the minus t times secant tangent e to the minus t. And so that's going to be multiplied times negative e to the minus t. And because the derivative of the chain portion right there, it's going to be negative e to the minus t. And it's going to be evaluated at t equals 1. And to the secant is 1 over cosine. This is going to be sine over cosine, or you can just use the tangent function in calculator. And so when you do that, that becomes approximately, I predid the work, so it becomes 0.152, and it's going to be negative, approximately. Okay, so that's part B. So part B, the answer is negative 0.4225 and negative 0.152, approximately. Let's do part C. Oh, before we do that, I'm sorry, we need to find the speed too as well. The speed function, according to the formula for parametric equation, is the square root of dx dt quantity squared plus dy dt quantity squared, evaluated at t equals 1. And so it's the square root of secant of e to the minus 1 squared plus the tangent of e to the minus 1 quantity squared. And I predid that on my calculator, and that should be approximately 1.138. Okay. Let's do part C now. The part C says find the total distance traveled by the object over the interval between t equals 1 to 2. And you want the total distance. I made a mistake on the first time when I did this with the student. So you have to be, I have to be very careful. The distance that it travels, the total distance that it travels is the integral. We're adding up all the integrals from 1 to 2. And if it's a parametric equation, is, square root of x prime of t squared plus y prime of t squared dt. And we can't do this by hand, so we have to use a calculator. And I'll show you how to calculate that a little bit later on. But anyways, let's do this problem. So that becomes integral from 1 to 2 of the square root of dx dt was the tangent, quantity of tangent e to the minus t squared plus 1 over cosine of e to the minus t, that quantity squared dt. And this is going to take a little bit of time, and you have to be very, very careful when you're using this calculator. So let's see if you can do this a little bit as fast as possible. First, you go to math and then press number 9. That's a shortcut to get to the integral. From 1, up arrow key, 2, use the right arrow key, and press the square root button. And you have to put parentheses around here. So it's a parentheses tangent of e to the minus t, negative, and I'm going to use the variable x instead, negative x. Get out. Right arrow key, m parentheses, and then m parentheses squared. There's a square button right there. Plus parentheses 1 divided by cosine of e to the, delete that, cosine of e to the minus x. Get out there, use the right arrow key, m parentheses, square that, use the right arrow key to get to the d, and then put x right there. And then when you press enter, it should evaluate that, and that should be approximately 1.0593. And I don't know if you can see this or not, but that's about 1.0593. I'm not going to get the phone. So that's part C. That's done. Let's do part D. That's the total distance that it traveled. Is there a time t greater than or equal to 0 for which the object is in the y-axis? Well, explain why or why not. And this is a little bit tricky question, and I really had to think about this a little bit. One of the things that you know about any function is the distance that it traveled is, so when you have a function as velocity of time, which is the first derivative, from A to B, that's the area. So that becomes the distance is equal to integral from A to B of v of t dt. So that's your basic concept that you're going to have to use. So and we start off at t equals 0 to 1. And you want to see what the x sub 0 look like. x1 minus x0, that would be the position of x at t equals 1 minus the position of x at t equals 0. That should equal the distance that it travels, which is from A to B of x prime of t dt, where A equals 0 and B equals 1. So this is our B right there, this is our A right there. And that kind of makes sense. Well, we have to figure out what x sub 0 is. This is the guy that we're looking for. So I'm going to move this guy to this side, move this guy to this side, and then so subtract the integral to the left side, add x sub 0 to the right side at time t equals 0, and then flip it around. So x sub 0 is equal to, move it over, x1 minus integral from 0 to 1 of x prime of t dt. Okay, and that's pretty important information. At x sub 1, which is at time t equals 1, they actually give it to you, the information at time t equals 1, the object of the position in the x coordinate is 2. So that becomes 2 minus integral from 0 to 1 of x prime of t. X prime of t would be tangent of e to the minus t dt. And we're going to evaluate this using a calculator, and that's going to be approximately 2 minus 0.77555, which is greater than 0. So the position at x is greater than 0, which means it's going to start to the right of the position of the y-axis. And since x prime of t is always greater than 0, that means for all t greater than 0, it's always moving to the right. That means it's never going to hit the y-axis at all. So you can explain that with words. I just stated it out. You can state whatever you want. But like I said, this is something important. That means that y as a function of t can never equal 0. Okay? Because it's always going to be to the right. It's going to be always positive. And this value right there at the x position is going to be 2 minus 0.7755. Good luck on the rest of your AP exams, and take a little bit of time, write every information down if you can, and start working on them. And all of it is mostly formula based, but you have to figure out what you're looking for. So good luck.